All right, with your groups, do extra example number 1. Figure out the measure of the 6 angles. See if you agree. Okay? I'll give you a minute or two, and then we'll go through them. Let's start in the back. Zoe, angle 1. 90 degrees is correct because of the box. Okay? David, angle 2. Because of 90 minus 60. Very good. Angle 3. Alexis. 60 degrees. Reminder, you've got the concept of vertical angles. Okay? Angle 4. Lupe. Is that what your paper says?
Yeah,
60 degrees? Everybody's good that if angle 2 is 30, angle 4 is 60. How about 30 degrees because of vertical angles are congruent? Angle 5. Nate. 30 degrees. Okay. And then number 6. Let's go Sam. Not 90. Because 6 is here, it's less than a right angle. Knowing that 5 is 30, 6 is 60. Okay? All right, so remember, think about the idea of complementary angles, think about the idea of vertical angles, think about supplementary angles. Okay? All right, go on to page 16. Point out some ideas to you. Okay, notice that the very first one, okay, we give you everything on the left. Okay, and what I want to try and do is I want to show you how it's put together. So, for example, they start out with G being parallel to H. So if I mark G as parallel to H in the picture, notice that angle 1 is on line G, angle 3 is on line H. What type of angles are 1 and 3? Corresponding angles. If the lines are parallel, what's true about corresponding angles? They are congruent, okay? And so that's why line 2 talks about them being congruent after the parallel. Now, we've got angle 1 is congruent to angle 2 because of the given. And so now, if I look at 2 and 3 put together, what do you notice about statement 2 and statement 3? What'd you say? Why is 3 congruent to 2? Because they're both congruent to angle 1. What property allows us to say that? Transitive. And so that's why line 4 has 2 congruent to 3. Okay, so do you see kind of the order in which they put it? So even though angle or reason number 1 is given, they didn't put the second given as line 2, they put it as line 3 because they wanted you to use the concept of the parallel lines. So what would be the reason for number 2? Hint, hint, hint. I keep talking about this idea of the diagonal method. If parallel, which we've already said that they are parallel in line 1, then corresponding angles are congruent. Okay? So if parallel, then corresponding angles are congruent. And we stated that they are parallel. Then we had our given. Okay? Now that we have the 2 angles congruent to angle 1, what property is that? That's the transitive property. Okay? Next, because angle 2 is congruent to angle 3, okay? Angle 3 is on line R, and angle 2 is on line P. What relationship do 3 and 2 have? Give me their name, their angle pair name. Alternate exterior. Okay? So, if alternate exterior angles are congruent, then parallel. So reminder, since we said that they were congruent, I started with congruent as the hypothesis. Whatever I'm trying to prove should be my conclusion. I'm trying to prove parallel, my conclusion should be parallel. So in line 2, I'm trying to prove congruent, my conclusion should be congruent. Okay, so those are important tips that you have to understand. That's the teaching concept. Okay? All right, number 2. This one, we're going to have to talk about this one probably together because there's a couple of new statements in here for you. Okay? Number 1, you got your given. ED is perpendicular to EF. Now, if two lines are perpendicular, do they form right angles?
Yeah.
All right. So our number 2 statement is going to be perpendicular lines form right angles. Again, notice perpendicular in 1. I'm using perpendicular as a reason in number 2. Okay? What does it mean for an angle to be right? Yeah.
It's gonna be 90 degrees.
90 degrees. So since I said DEF is a right angle, now I'm going to use that down here and I'm going to say definition of right angle. Okay? A right angle is 90 degrees. Okay? Now, that is kind of like where a break happens. Now we're on to a new concept. And a new concept has to do with angles 7 and 8. So look at the statements below. It talks about 7 and 8 being 90 degrees and 7, 8 being complementary. Well, somehow we got to go from DEF down to here. How are we going to do that? What's going to be our transition? And think about what it says as the reason. Angle addition postulate. Does anybody remember what the angle addition postulate is? Yeah.
When they both add up to 90?
Do they have to be 90?
Now, just like any, well, something like that.
All right, it's 2 angles that add up to be the bigger angle. So give me 2 angles that add up to be a bigger angle.
45, 45.
Well, it doesn't have to necessarily be numbers. Give you a hint. What if I said the measure of angle 7 plus the measure of angle 8? Okay, so the measure of angle 7 plus the measure of angle 8 equals what?
90.
Not 90, because that's already line number 5. Oh, very good. The measurement of angle DEF, which basically says the big angle DEF is equal to the sum of the 2 smaller angles. That's the angle addition postulate. They don't necessarily have to be 45 and 45. They could be any 2 angles. Okay? Now, how did we get from 7 and 8 adding up to be DEF to 7 and 8 adding up to be 90? Hint, hint, hint. Look at statement 3. Look at statement 4. And then see how it changed in line number 5. Substitution. Since DEF is 90, we changed the DEF to a 90. So that's substitution. Okay? And then, if 7 and 8 add to be 90 degrees, does that mean that they are complementary? So that means definition of complementary angles. Okay, and again, I'm just trying to point out how the process works, that what we state over here a lot of times is a reason below it, okay? All right, so skip number 3 and go down to number 4. And I want you to try number 4 with your table. See what you guys can get. So, this is the way it should look. The big thing that I want to point out is please make sure we understand it has to be VAT and it has to be written in if-then form. Okay, and then you can see you've got your transitive there. Yes?
Would it be wrong if we put 1 as congruent to 2 first?
So if you flip-flopped these two, Okay, as long as you're flip-flopping the statements with it, you're fine. Yes, okay? No big deal there, okay? Would it be wrong what?
What if you said if they're alternate exterior angles, then they are parallel? Is that wrong?
Okay, so what we're trying to do is we're trying to show or prove the exterior angle theorem. And the way we're trying to do that is by using a different property in order to get there. And so that's why we didn't use the idea of alternate exterior angles, okay? All right, let's try one more. Number 5, see what you can do. So starting in the back, let's go with, Philip, line 1. Giving you the easiest one.
G parallel to H is given.
Very good. Okay? All right, so if you need to, I fill that out. Okay? Now they gave us parallel lines for a reason. I'm looking for an angle on line G and an angle on line H that, have some type of relationship. So Karina, did you find a relationship for line G and H? Well, we already have parallel. I need a set of angles. All right, Nate.
1 and 2.
Not 1 and 2 because 2 is,
G and H.
yes, angle 1, but all right.
2 and 3.
If you have 1 and 2, give me a name for 1 and 2.
Oh, corresponding.
All right, so 1 and 2 are not corresponding. Which angles?
3 and 2.
Not 3 and 2.
1 and 3 and 1 and 3.
1 and 3. Angle 1 is congruent to angle 3. Okay, and like we've been doing over and over and over again, if parallel, then corresponding angles are congruent. You have to write the congruent, Lupe. Okay? Now, I use the concept of the parallel lines to show that 1 and 3 are congruent. Now I'm kind of like done with that concept, so I have to start all over again. So what should the third line be? Angle 1 is congruent to angle 2, and your reason is given. Now I've got line 2 and line 3 kind of put together. Okay? So Marcos, what should we do next if angle 1 is congruent to angle 3 and angle 1 is congruent to angle 2? Angle 2 is congruent to angle 3. Do you remember what property allows us to say that? Transitive property. We're doing good. Okay? Now, we're down to the end. Okay? And so now we're going to say P is parallel to R, because since 2 is congruent to 3, and 2 is on line R, and 3 is on line P, and they share that transversal, what type of angles are 2 and 3?
Oh, I have an if that.
We do have an if then.
Oh, if corresponding angles are congruent, then they're parallel.
All right, if corresponding angles are congruent, then parallel, okay? So things to point out. Notice on line 2, we said congruent, we finished with congruent. Line 5, we said parallel, we concluded parallel. Okay, those are the teaching points that you have to understand in order to help do this, okay?